Sweet. All right, well, let's get into it then. Oh, let's turn that on too. I forgot to do that when I walked in. Today, the big part of today. So, any textbook, any stat textbook that you use, any stat textbook at all that you use, whether it's a freebie like I gave you, or whether it's one that you pay $200 for, written by the most renowned statistician on earth, they all have the same problem in the beginning that I've noticed. They front load too much stuff. I've heard this from many students. The first couple days of class just seem like an open up your brain, let me pour stuff into your brain kind of experience. And I get that, I totally get that, and I'm trying to avoid that. So what I've done is I've gone into your textbook that does the exact same thing, if I was to go through the textbook exactly the same. And I've taken out the stuff in the first few bits of the textbook that's important right now, and the rest of it we'll get to later. For example, a textbook will say something like, here's the formula for a z-score. Remember this, because in 7 weeks, we're going to use it. Right, exactly. I imagine my son, who's 6 years old. Here's how you fly cast, Max. Now, when you're 16, we'll go steelhead. It's not going to work unless you're using it right then and then constantly using it. So what I've tried to do is I've tried to extract out the first parts of the text that are relevant to what we're going to be doing starting Tuesday, and the rest, like ogives and box plots and z-scores and percentile ranks, will show up when we need them to. Also, this entire bit of information will be online for you guys. Don't feel the need to have to write all this stuff down. There's going to be a lot of graphics involved in this, a lot of little text, a lot of screen captures from Gallup polls. I'd rather you stay with me in class and be part of the conversation than try to scratch it. Write down whatever you need to write down. We're going to add stuff on the board too as we go. But don't feel pressured to write everything down that's up here, because we'll have it. First of all, it's going to be kind of sparse in places. And secondly, you'll have access to it. Everything I use is yours. So, anyway, yeah, stuff from the first bit of your book that you need to go right now. That's my favorite title. It's a little too long. Too long to be a working title, though. So the big thing, this is what we're all about in this class. And really, if you think about it, it's what we're all about in the world. It's how our world goes round. It's why you pay what you pay for car insurance. It's why you pay what you pay for a textbook, in this case zero, but it's why the textbook industry sets their prices the way they do. Okay? It's why doctor's bills can seem ridiculously high when you have to pay them. If your insurance runs out or you're not covered. It's all based on data. It's all based on data. I met a friend's daughter yesterday who's an actuary. And their job, actuaries' jobs, I couldn't do it just because I couldn't sit in a cubicle all day and crunch numbers. I went, hi, don't be sorry. Their job is to set things like how much you pay for a year's worth of life insurance. We're going to analyze that later in this course. We're going to analyze me, my chance of dying in the next year, my chance of becoming disabled in the next year, my chance of being okay in the next year, how much it should cost me for a certain life insurance policy. And you're going to use the idea of probability, which is tied back to this idea of data. So it's all about watching the world and seeing what the world is showing you and making good decisions based on that. And not decisions necessarily from your gut, but decisions based on what the data is showing you. That's what this whole course is about, is looking at that data. What can it show us? Not trying to necessarily prove something with it. Sometimes you can. But just what is it showing me? What's it trying to show me? What's under there? What's interesting? So anyway, that's that. I like to break it into two parts, though. I like to call some of it qualitative and some of it quantitative. And the reason I like to separate, you don't really have to, but I think it's clearer if you do, because there are certain things you can't do with qualitative data that you can do with quantitative data. So qualitative data essentially is any data that's not a number. Not a number. For example, what style car you have. What style car you have. What kind of tires are on that car. Do you put studs on or do you not put studs on? Those kinds of things. Sometimes this can get tricky, and we'll talk about this more as the course goes on. Sometimes qualitative data can look like numbers. Like they may say, put a 1 if you have a Ford, put a 2 if you have a Chevy, put a 3 if you have a Lincoln. And then all of a sudden there's a number there, so you're like, oh, this is quantitative. It's not really, because if I changed the labeling of that, it would change the numbers, but it wouldn't change the meaning. And that's bad. You don't want to do that. It's like, how much do you weigh? I'm 175, or I'm 140, or I'm 210, or I'm 62. Like you wouldn't like that very much. But that's what you would do by applying numbers to qualitative data. You have that exact same problem. So things like colors, what credit card did you use to pay? Are you religious? If you're religious, what's your affiliation? What's your political party? All kinds of those kinds of things, right? What color are your socks today? 0. So anyway, that's qualitative. As such, there's not a whole lot you can do with it. You can count it. We'll do that a little bit later with some data we collect in class. You can count qualitative data, but that's really all you can do. And more on that as the course unfolds. There is some stuff you can kind of do if you're careful. We'll be careful as we go, I promise. So I want to talk more about the stuff we can do more with, which is the numerical stuff, also formerly called quantitative data. Yeah, good stuff, good stuff. This wouldn't be necessarily what's the style of car that you drive, but how long is your commute to school? Is it between 0 and 3 miles? Is it between 3 and 5 miles? You break it up in some way, perhaps. How long does it take you to get? So you said it took you an hour and 40? I think you said that, right?
Yeah.
Hour and 40 to get to school, which I'm assuming it usually takes you about 25?
45.
45, there you go. So this is an interesting thing to look at the difference in the time commuting based on weather. How did it affect? Did everybody else have a longer time getting to school today than usual? Only a couple of you. Anybody have no problem at all getting to school time-wise? The vast majority of us. Interesting. That makes you an outlier. But it's interesting because were I to make a conclusion based on the entire class on just what Serenity said, right? Based on just what you said, I would think, my God, the class had a hard time getting here. Because you're the only person that vocalized it. But that often happens in statistics. We get the unusual to be more visible than the usual, i.e. Jared from Subway. Perfect example. We'll get more to him later. But that's a perfect example of what's called an outlier governing the data set or steering the data set. That's why random sampling is so important. Getting ahead of myself when I'm getting excited, but we'll get back to that. We'll get back to that. So anyway, these quantitative data, this numerical data, I like to subdivide it even further, and I kind of build a course around this too. If you count it, it's discrete. And if you measure it, it's continuous. That's just terms that have been handed down to us. Discrete items versus continuous items. So an example would be simply counting you guys as you walk in the door. 1, 2, 3, 4. Counting the number of eggs my chickens lay. We're going to track their egg production on your first exam. I've got about 4 or 5 months of egg production that I want to have you guys analyze and crunch for me and be able to answer the question, how many eggs did your chickens give you? Like, well, you're going to answer that question for me based on the data. So you count that. You go out there, there's an egg, there's 2 eggs. Holy crap, 5 eggs today. 4 chickens, 5 eggs. What the hell just happened? So that's the kind of stuff. That's the kind of stuff we can look at countable-wise, right? How many cars are parked in these spots, right? How many cars are illegally parked in my bike lane on College Way? That kind of stuff. So those are counted. Those are counted. Measurements are trickier. You see a lot more of this in the news than you see this in the news. And most of the reason is, that doesn't mean there's more of this than this out there. It's just that this doesn't make the news as much as this. The vast majority of studies you hear about on the news deal with percentages, as you may have noticed. You know, this percent approve of Obama, this percent approve of Congress, this percent experience headaches after drinking too much caffeine, blah, 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 blah. Well, that's because it's simple to collect that data. Once you've defined the variable, i.e. do you have a headache, then it's just a matter of taking 1,000 people and saying, how many of you got headaches? 1, 2, 3, 4. Piece of cake. Trickier would be, let's measure the blood pressure of those who took the caffeine. Because then it's not just 1, 2, 3, then it's give me your arm, put a cuff on it, which I still think is magic, by the way. Any nursing students, I think that's magic, and I'm so fascinated by the whole, I try to do it with the nurse while they're doing it, I don't know what the hell they're doing. But the measurements are very often trickier to do than simple counts. Fortunately, there's not much that you have to measure. As far as I can tell, there are only 4 things that are measured. Can you give me one of those 4 things that you would measure? And blood pressure is a good indication of that. Say that again.
Time.
Time is definitely one that you measure. It's a continuous quantity. You don't count time. I mean, you can like look at the clock. Like this clock clicks on the second. I'll stop doing that now. But there's time between that. So you'd have to measure the time sweeping out. Good. Time's 1. Thank you, Rich. Please.
Weight.
And tell me your name again.
Corbin.
Corbin, thank you. Yes, weight is another one. Weight is another, you weigh yourself. You don't count your weight, you measure your weight. Nathan, go.
Distance.
Distance is a perfect one. Yes, you measure your distance, or your height, distance, length. We can make it more general. Distance, we got distance, weight, time. You guys are fantastic. What's the last one, Rebecca?
Speed.
Speed is definitely continuous. I call that a combination of distance and time.
Okay.
If that's okay. I try to simplify rather than, I mean, speed definitely. Volume would be a continuous measure, although that's just length cubed. Area would be length squared. So yes, speed is for sure continuous, but it's also just distance over time. Good, so you got length, weight, time. There's one more you probably dealt with today. Temperature. It's colder today than it was a couple days ago. How do you know? Because the little thermometer thingy went down. It's lower than it was, or your Newton's barometer thing dropped more balls to the bottom. It's colder now, or maybe they went up to the top, I forget. But regardless, it's measured. It's measured in some way. Anything that's a combination of, like blood pressure, I believe, how the hell is blood pressure measured? Milligrams? No.
Millimeters.
Millimeters, thank you.
Of mercury.
Of mercury. So millimeters is a length. Boom, right there. Right. Density of an object, volume per mass, which is then a measurement of weight and or length. So, I mean, there's always, they all kind of distill down to 4 things. I can't think of a fifth. I keep trying. I just can't think of a fifth one. So I think those are the only ones. Those are the things you have to measure and you can't count. And those are trickier. Rebecca, what do you got? Oh, I'm sorry. So there you go. There's your 2 kinds of data. We'll deal with we'll do a lot of counting today. Yeah, is it all counting? I think it's all counting today. It's tricky to get continuous data in class because whenever I try to measure something in class, I have to deal with precision issues, and precision pretty much goes out the window because I usually bring things like paper rulers and things like that. Here's a paper ruler, measure a foot, and you're like, this is 18 inches long. Yeah, so we try to keep it discreet for the most part in class because it's easier to get the data. But I will track down, I promise you, I will track down for you good data. Like this one, I think this is great data. I think this is great data. You don't know what that is yet, but maybe you do. You probably can figure it out just by looking at the colors on it. The first type of data analysis. So now you've got your data. What do we do with it? I want to talk about descriptive versus inferential stat. Descriptive versus inferential. Rebecca, you're talking about research methods class. That's the fusion of both, which is fantastic. So let's look at each one in turn. Here's a map of the United States. It's just a contiguous, not Alaska nor Hawaii. I think Alaska went to Romney, and I think Hawaii went to Obama, I think. And I think it's fairly normal for Alaska to go conservative and Hawaii to go more liberal. But this is what happened electoral-wise in 2012 between Obama and Romney presidential campaign. Obama got 50.6% of the popular vote. Romney got 47.8%. The astute among you might notice that doesn't add to 100%. That's because my friend and yours, what the hell's his name? Northeast Oregon loves. Oh, I forgot his name now. Ron Paul. Ron Paul and a few others, handfuls. Ron Paul. I think every person that loves Ron Paul lives in Pembroke. You ever drive out there? Barns with huge Ron Paul banners on it. It's fantastic. Like,
I love Ron Paul.
What's that?
I love Ron Paul.
I didn't say you didn't. I'm just saying Northeast Oregon loves him more. There was actually a flyer on a telephone pole in Bend all about Ron Paul. Ron Paul didn't save America. It was just awesome. I think he's great. I love some of what he stands for. I love some of what everybody stands for. I just need to slam them all together into one person I completely agree with.
Wouldn't that be great?
That would be great, and probably illegal. So here's, the popular vote doesn't add to 100%, but the electoral vote does, because unfortunately this is a system we use to decide the president, which, anyway, we'll get that discussion over coffee sometime. But notice, if you look at that map, what color is predominant?
Red.
Red. But yet Romney only got about 40%, where Obama got 60% of the electoral vote. Now, I want to pause for a second. I think you know why it looks like that. But I want to talk about why this is called descriptive statistics. This is data we've already had. The election was over in 2012. Months later, all the votes had come in. All the votes had come in. And then we simply collect them into a chart and then slap them up in some way, in this case, using a map of the United States. Which is, I think, more interesting than putting Delaware, boom, boom, Arizona, boom, boom, New Mexico, boom, boom. This is kind of more clever. Although, what's the problem is, the red looks like it's more than the blue, and why is that?
Red states are bigger.
Bigger in area?
Yeah.
That's true, but California's pretty big.
Well,
It's all
you have Texas,
together,
Montana,
it's
like, there's just more area being taken up by red.
Right, exactly, but there shouldn't be by these numbers.
Well, it's defined by population.
That's the problem. The Electoral College, except for 1 or 2 states now, I can't remember. It's either all or none. The state either goes completely with or completely against a candidate. And then there's 1 or 2 states that give them a mix. I forget which one it is. It's not indicated here. But Texas is all red, as is Oklahoma is all red, as is Wyoming is all red. Now the problem is, Delaware, find Delaware. My home state.
Northeast.
Find out, northeast.
To the right of
Here, I'm gonna leave my finger down. You stop when I get Delaware.
Stop and
Keep going down.
Keep going down, yes.
oh, you did?
Yeah.
There we go.
Right there. Little armpit. It's even shaped like an armpit. It tucks into Pennsylvania. They broke it off with a 12-mile circle. So only 2 states with a circular border. That's our claim to fame. Anyway, Delaware went blue, and Wyoming went red. And the problem with it is because we're looking at the map scaled by not by population, it looks like Wyoming is more red than Delaware is blue. There's actually way more people in Delaware than Wyoming, believe it or not. Here's what it should look like if you draw the map scaled to population. Now, do you see it 60% blue? Yes. Now you actually see 60% blue. There are 900,000 people-ish in Delaware, and only 600,000-ish in Wyoming, which I can't even find. Oh, there it is. There's Wyoming right there. And now they're scaled properly, so you actually get an idea of how big they should be. I still think Delaware's a little too small as far as that goes, but I think whoever drew the map drew it rectangularly and not triangularly. So if you drew the triangle out to a rectangle, it would be the correct size. Whatever. You get the point, though. Now you can see the 60% to the 40%. For example, California swells, New York swells based on population. How did Oregon do? I covered Oregon with Wyoming. It's up there somewhere. There's the Dakotas. And Texas. Texas didn't change a whole lot, I mean, size-wise. It's a big state, there's a lot of people in it. So, kind of cool, huh? There's Pennsylvania, there's Jersey. Unfortunately, sure. I love Jersey, don't get me wrong. Okay, now this is one way of looking at it. Here's another way of looking at it. This is the normal proportioned U.S. map, but broken down by county instead of state. Now this looks even worse from a blue-red perspective, because now we've lost even more of the electoral. And again, why? Population again. Find LA on that map. And while you're at it, find New York City on that map. New York City, LA, two of the 2 most populous cities in America. Yes? Let me try to take Austin off. Austin is here. New York and LA, 2 most populous. If you put the populations of, this was true in the 90s, it might not be true anymore. If you put the populations of New York City and LA together, that's more people than live in the entire country of Canada. That was true in the 90s, it might not be true anymore, but it's probably damn close. That's kind of staggering to think about it. Can you find New York? Can you find LA?
Yeah.
Can you find them now? Yes. The big blue splotch is LA down there in the bottom left, and the upper right, the big blue splotch is Long Island looks ridiculously massive sticking out there. Whereas Cape Cod still looks adorable. So cute. So cute. Okay? So again, it's getting a little ridiculous, but and again, you can once again see the 60-40 split. But this might not even tell the whole story. One of the problems people have with the Electoral College is that it's all or none, and you lose the gray between, or in this case, the purple. So here's one way of looking at it. Split the counties by percentage conservative, percentage liberal. So the more blue, purplish, the more liberal, the more red, purplish, the more conservative. So the redder, the more conservative, the bluer, the more purple. But again, it gets a little hard to look at. This doesn't get much better when you put the counties by population. It starts to look like the stuff my son does with paints in his thumbs. So we've lost the states completely now, except for Florida, which is down there. You can see why Florida creates such issues, though. When Florida screws up, you can see why it hurts so bad. There's so many people there. And when they have an issue like in the 2000 election, I think it happened again in the 04 election even, not quite the scale it was in the 2000 election, but you can see why it has an effect. If Wyoming has a problem with the voter polls, it's like, whatever, it's Wyoming. It's like 2 people there. But when Florida has a problem, it's a huge issue based on weight. But here's the deal. Every one of these maps, which one was your favorite of the 6?
That one.
Oh, that one.
So, who liked the original the best? Just curious. Okay, who liked the second one the best? Yeah, second was pretty sweet. Third one? By county? Fourth one by county. With the cool. Yeah, okay. How about this one? Counties with the sweet smidges? How about the Rorschach test? This last one here. Interesting! Only like 10 of you voted, that's okay. The rest of you hated them all equally. That's good. But nonetheless, all of these are what's called descriptive, because all of these maps were created after the election was over, once we had all the data. And it's pretty much inarguable. It's just, that's what happened, you know? It's like, okay. It's kind of like when you take a baseball card and turn it over. It tells you how the player did. They still make baseball cards?
Yeah.
I think they do, right? Yeah. Digital age hasn't removed that completely yet. So you turn a baseball card over and it tells what the player did for the past, whatever, 5, 6 seasons. You open the newspaper or turn on your smartphone and look at the news. Oh look, this is what happened in Pakistan yesterday. This is what happened in Europe yesterday. The euro fell again, or the euro is stronger against the dollar again as of yesterday. Those are all descriptive because it happened, it's reported on, and that's it. Compare and contrast that with the guys and girls that stand outside of voting booths on election night, taking what are called exit polls. And what are they trying to do?
He said so. How people are voting.
Yeah, tell me your name one more time.
Holton.
Holton, thank you.
Yeah.
Trying to get a sense of how they're voting because
They want to predict how
They-
everyone voted.
oh, I love that word. They want to predict what's going to happen. That's a different story, isn't it? Because that's arguable. As a matter of fact, I think they should stop doing exit polls altogether.
Yeah.
Because they're horribly confusing, first of all, and they flip-flop constantly because of random fluctuations, which we will study in here. But nonetheless, they are trying to do predictions. They are trying to do predictions. And that's where this bridges a gap into what I like to call statistical inference. Inferential. Now, the lion's share of what we do in this course will be descriptive in nature, where we collect data, summarize it in some way, and then report it back, or discuss it in some way. The lion's share of what we're going to do in here is not going to be inference. This is pretty much Math 244's realm, but for those of you, there's only a handful of you taking Math 244, I believe. I want to give you enough of this in this course so that you can go at least read the newspaper more intelligently. Because I know you can do it. You can do it better after today, guaranteed. I'm going to have you guys paying attention to something you might not have ever paid attention to before today. And it'll help you be more intelligent consumers of, I'm not calling you unintelligent, but more intelligent consumers of data and information. Even better than most of the news anchors that are just reading off of a sheet to understand what they're even saying. So, here's 3 words, or 2 words I haven't defined for you yet. There's your word, predictions. Makes predictions based on a random sample taken from a population. I have not defined either of those. So I'm going to have you guys define it. What do you think a population is? What do you think a population is? When you hear the word population, what do you think? What do you think?
Group of people.
Oh good! A group of people that you're interested in what? Yeah, I think you want to study it. You want to know something about it. For example, the voters, right? If you got these exit pollers that are asking, who are they asking? Every person that comes out? Maybe every 10th person, something like that. Maybe some randomly just designated number, like they have a little die in their pocket, they roll it. Ask the 3rd person. Ask the 20th person. Ask the 15th person. I wish they would do that, actually. That would make me happy. If I saw a guy rolling a die and asking that, I would be so stoked about that. More on that later. But they usually pick a number like 10. Every 10th person, which is very interesting because, you ever heard the word decimate? What does decimate mean? Say that again?
Separate into 10.
Exactly. You know where it comes from? The Roman army used it as anybody that was accused of desertion was lined up in a line and they killed every 10th person. Decimate. That's where that word comes from. Decimate, and a more general term is to eradicate, to knock down. Something was decimated. It comes back to that idea of every 10th person dies, every 10th person dies. And that's very often how things are surveyed. Every 5th, every 10th, every 20th, or something like that. Hi, not a problem. So anyway, more on that later too. But the idea of a population is you're interested in studying them. So exit pollers are interested in who? They're interested in voters. So they're going to draw a sample from the voters. Now the trickiness is it's got to be a random sample. What does that mean?
Not every 10th person?
That, well, depending on how you set it up, it could be viewed as random. I like that. Certainly says that's not random. If you start it with a random value, you can do it, it's called systematic sampling, which is arguably unrandom,
Right.
but you can make it more random by starting with a random value. So say start by rolling the die and say, okay, it came up 15.
Okay.
Start with the 15th person and now ask every 10th. That's a good kind of sampling if you know you need to get a certain amount done, but I agree it's not as random as my personal favorite random sampling. So what do you think? How else can we do it?
Blindfolded.
Oh, that's good. Suppose you guys are my population. How many of you are in here today? What do you think? 35? 35-ish. Let's make it 35. I'm going to draw a random sample of 3 of you. Random sample of 3. Tell me your name. Susan, tell me your name. Bailey, tell me your name. Okay, Susan, Bailey, Michelle. There's my random sample. Done. What do you think?
Not random.
Not random? Dare you swear? Okay.
It's all in the front row.
All right, hang on now. Susan Bailey Rich. Random sample.
Maybe.
Oh, I like that. I like that maybe. Tell me your name again.
Lauren.
Lauren, thank you. I like that. Next random sample.
Michelle.
Bailey Michelle Lauren. Lauren Michelle. Lauren Michelle Austin. How are these random samples doing?
They're not, you just say people's names. You know.
Well, the problem is I'm thinking people I know I've learned your names at least in the last 3 seconds. So there's definitely not random right now. I like the maybe though that Lauren said, because what would be a really good way of drawing a random sample from this room?
Names out of a hat.
That's perfect. Put all your names in a hat on the same size piece of paper. Shuffle them up, reach in, grab, just like you do with the lottery, with Powerball. With a little air-filled thing. They still do that with the air-filled balls, the ping pong balls. That's the perfect random number generator. Yeah. The problem, of course, is it would take a hat, which I don't have, we got some baseball caps. We could also do it by assigning each one of you a random number, or a number, I should say, 1, 2, 3, 4, 5, and then generating 3 random numbers with technology, which we will do. That's not as good as the numbers out of a hat. We'll talk more about that as we go. But anyway, you cut it, there's about, can I say there's 30 of us in here just to make the math easier? Let's say there's 40. If there were 40 of us in the room, if I selected 3 of you at random, there'd be about 64,000 possible samples. Everywhere from 1, 2, 3 to 1, 2, 3 and everything in between. So when Lauren said maybe, she's correct in saying maybe, because any one of those 3 people that I just picked is going to be one of those 64,000. It's just how likely is it going to be A, somebody close to me, or B, somebody whose name I already know. That's starting to look more like bias, isn't it? Yes, good. Lauren, go.
Yes, or on Tuesday when you were showing us the heads and tails thing, how things went in sequences.
Well, clumps. Yeah.
Clumps.
In that case, a sequence of 2. Yes, go.
I just was kind of thinking when you moved your way around the room, you started with
Yes.
those two, and then you know.
And then I did you and these 2 intentionally because I wanted a small clump and then one that wasn't a clump. It becomes the notion of what feels random to you versus what is arguably random. And that's what this whole class and a lot of 244 is about, is trying to design, is it random enough? We actually test an iPod in 244. Is the randomizer actually random enough? Is it showing us enough of the songs over 50 shakes? Things like that. So, and we're notoriously bad at judging randomness as humans. I took a CPR final for Jenny Cruikshank. I don't know if you guys know Jenny, she's rad. Teaches a CPR class. And it was a 25 question multiple choice exam. A, B, C, D. And I'm taking the exam, A, and I start smiling. A, B, B, A, B, B, C, 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 C. And I start smiling, looking around the room, and the kids are freaking out. They're like, oh my God, because it didn't look random. I mean, I knew it from the 5th question, but there's too many freaking A's already. At least my gut was telling me that. And the kids are freaking out, they're erasing and changing. Don't change that, you got it right. You got it, don't change that, you got it right. They're changing it. They gotta go A, B, C, D, A, B, C, D, A, B, C, D. And you could run a statistical test on that. I had my 244s do it. And as it turns out, I was wrong. There weren't too many clumps, statistically. My gut was saying that there were, but that shows how crappy we are as humans at judging randomness when it gets close to the transition between too much and too little. So that's why it's so important to utilize technology when possible to set up random sampling, because otherwise you fall guilty to your gut making the shots for you. And then I start listening to Serenity talk about how it took her an extra hour to get here, and I think all of you did. That's hardly random sampling, that's the one that told me sampling, which is called convenience sampling. Good, let's go to this little guy here. Study claims caffeine addicts get no jolt from morning coffee. Take a look, read a little bit of it. If you can, I don't know how many of you guys, the text is kind of small, I apologize. See if you can read some of that. Psychiatrists are poking holes in the study. That happens all the time, by the way. Regular coffee drinkers build up such a tolerance to caffeine. Their daily job does nothing more than bring them back to normal levels of alertness. I saw a bunch of swimmers in the locker room today, a bunch of high school kids just dragging through I mean, these guys swim. I'm swimming 3,000 meters. They're doing like 8,000 at the same time I'm doing 3. It's insane. And they're like, can we go to the store and get some energy drinks? And I'm thinking, oh my God, these kids are like 16 years old and they're already drinking Rockstar to stay awake for class because they just did, granted, an insane amount of exercise, but I wonder if just eating and sleeping would help that too. But I guess when you're 16, that's not cool. Anyway, who's, not at all. Who's my population? Whether, I don't care about the psychiatrists that are poking holes in the study. The original study and or the second study, who are we studying? Caffeine addicts, according to them, or just people that use caffeine a lot. People that consume caffeine a lot. Maybe coffee drinkers? I'm not sure who exactly they studied, but I'm going to go with
other caffeinated drinks.
and other caffeinated drinks. So caffeine users, beautiful, awesome. Got to read these things carefully to pull that out. Don't just go with the headlines, please. Don't just go with the headlines. So caffeine addicts is our population. We want to know about caffeine addicts. I want to know about this jolt thing. Okay, let's pretend we've defined what this jolt actually is. Now, I'm sure that somehow they measured this. Normal levels of alertness. We have to measure that somehow, yeah? We do have to measure that. And we can measure that maybe with like a blood pressure reading. Maybe we measure alertness with blood pressure. Maybe how well we do on a memory recall kind of a test. Sometimes that works. So let's assume that the measurement was done correctly. So I want to be able to get this data from caffeine addicts. I'm going to go out and find every caffeine addict I possibly can until I get them all. Yeah?
No.
All right. Is that a random sample? No, I'm not going to do that.
No.
Why am I not going to do that? Tell me your name.
You can't get them all. Carolyn.
Carolyn, I can't get them all. Why?
There's too many.
Exactly. This is generally too big to count. Do you know what it's called when you count every member of your population? The United States government tries to do it every 10 years. It's called a census. And even the Census Bureau is going, Uncle, there's too many of you now. It was great in like 1775 when it was like 20 of us. Yeah, let's go down the road and count George and Tom and John and their horses. Yeah, but it was great. It was 20 people. And they're all in Virginia, right? But now there's 310 million Americans. You can't do it anymore. It's getting harder and harder. And even the Census Bureau is saying, we got to use random sampling techniques because there's just too many people in the country now. So yeah, that's called a census. Carolyn's right. Too many to do. So what do?
Randomize this.
We randomize the sample. Where's their sample? I drew a big red circle around it, or an oval around it. 379 adults who gave up caffeine for 16 hours. Now, Carolyn, this is why you got to read carefully too. The population is caffeine addicts. When you look at the sample, it's adults who gave up caffeine. So you got to be careful. This doesn't mention that it's adults. You might inadvertently think kids are looped in there too. That's why you got to look at both to make sure. Because sometimes the population, you might say, what's your population? Americans. It might be voting age Americans. It might be continental US Americans. It might be male Americans or female Americans or Democratic Americans. And that can skew the results in ways you're not prepared for if that's not indicated. The problem with headlines is they're often very short and they're attention grabbing. And they hide stuff to make it attention grabbing. So it's not exactly untruthful, but it's untruthy. If you use Stephen Colbert's phrase, the truthiness is a little bit suspect. So it can't be argued that it's false, but it's kind of hard to argue that it's 100% accurate as well. So, population in this case appears to be not just caffeine addicts, but also adult caffeine addicts, yeah? And there's our sample, 379 adults. And don't worry about what they did in the study. We'll get into that in 243 later on in 244, definitely. Just right now, be able to look and find your population in your sample. Here's a good one for you. Oh, sorry, I forgot to define this here. As Carolyn pointed out, we can never measure the population directly. The problem is we want to. We want to measure them. We want to know what's going on in the population because we want to know a parameter, which is a measure of the population. We want to know on average, how does the blood pressure change in a caffeine addict who gives up his coffee or her coffee? That's what I want to know, but you're never going to know what it is. The best you can do is take your sample of that 379 adults, measure them, and then make adjustments to that measurement to make it apply to the population. More on that in about 30 seconds. But that's why this course is called statistics. Because statistics is the study about how to do that properly without bias, or at least with minimizing bias. It's not called parameters. If this course was called parameters, you come in on the first day, I'll teach you how to count and send you on your way and said, good luck counting everything. And you'd hate me. Because it's impossible, as Carolyn pointed out. It's called statistics because we can't do that, and even if we could do it, you don't want to do it. My brother-in-law worked for FIA, Forest, what does that stand for? FIA, it's a governmental entity. But his job essentially was to go into the woods to a pseudo-randomized spot, subplot center I think he called it, boom, and then he would work out from that and count all the forbs, I think it's a word, grasses, bushes, trees, all kinds of stuff in that subplot. mark it all down, record it, and then they would go back over the course of 10 years and visit the same spot over and over again and keep track of basically understory growth and did burns come through and are things growing or things dying off. And the idea is you're not counting every bush in the forest, but you're counting a randomized sample of things in the forest to kind of keep track about what's going on. Anybody, who's in natural resources? A couple of you guys? Yeah. You guys, have you done the Pilot Butte thing yet? The Pilot Butte grade measurement? That's a really, really fun one you guys will do. Measuring the, well, I'm not going to say too much about it, but you're out there in the woods all the time collecting data, which is super fun. So we'll get into that. Or you'll get into that with Brett, folks. Good stuff. Here's what I want. You know what? No. It's 11 o'clock. I want you to walk outside, get some air, get some water. The sun apparently just came out. That's nice. Go wander, get some vitamin D. Come on back in. We'll do some more of this.
Shut this down.